Basically meant a 5-minute pit stop, right?
Yeah.
You've got that distinct smell of gasoline, the muscle memory of squeezing that heavy metal handle.
They're totally ingrained in us.
Exactly. But if you look at the 2026 data we're diving into today, that ritual is, well, it's about to become completely obsolete.
Oh, absolutely.
We are moving toward this world where
Yeah.
your car isn't just, a vehicle to get you from point A to point B. It's rapidly becoming a mobile power plant.
Which is wild to think about.
Right. So today, we're looking at a huge stack of sources. We've got the IEA's Global EV Outlook 2026, some really detailed tech specs on BYD's Megawatt Flash Charging 2.0, an industry explainer on vehicle-to-grid tech, and some breaking news out of Volkswagen.
It's a lot of ground to cover.
It is. And the mission today isn't just to throw numbers at you about how many electric vehicles are on the road. Whether you're a die-hard EV fan or you're just sitting there wondering when to finally ditch the gas pump, we're going to explore how these cars are radically rewriting our relationship with the power grid itself.
Yeah, and I think, the sheer scale of what happened globally in 2025 is really what sets the stage for that whole power grid revolution.
Right.
According to this new IEA outlook, global EV sales officially topped 20 million units in a single year.
20 million.
Yeah. We are at this point where 1 in 4 new cars sold literally anywhere on the planet is electric.
That's just, the macroeconomic ripple effect of that is what really stands out to me because the data shows those EVs are actively displacing like 1.2 million barrels of oil per day.
Which is a massive chunk of demand.
Right. When you consider that the road transport sector traditionally accounts for, almost half of all global oil demand, shaving off over 1 million barrels daily fundamentally alters energy security.
It really does.
It gives countries that, rely heavily on imported oil a completely different geopolitical hand to play.
For sure. But that leverage is currently distributed very unevenly depending on what region you're looking at.
Okay, how so?
Well, Europe experienced this massive 30% jump in EV sales in 2025. That pushed them to a 28% total market share.
Wow, almost a third.
Yeah. But meanwhile, the U.S. market hovered just under 10%, and it actually saw a slight dip late in the year.
Oh, really? Why the drop?
It was largely because those federal tax credits were expiring, so consumers just kind of pulled back.
Ah, right, the tax credits. But here's where it gets really interesting, I think. The U.S. and Europe always dominate the headlines, but the IEA report highlights that emerging markets are suddenly the ones just exploding.
Oh, yeah. The numbers there are crazy.
Southeast Asia literally doubled their EV sales year over year, and Latin America jumped by 75%.
That's huge.
Yeah, and if you dig into the why, it really comes down to raw fuel price sensitivity. With all the global energy volatility, driving a standard gas car in those regions just became punishingly expensive.
It hurts the wallet too much.
Exactly. The pure everyday running costs of an EV suddenly outweigh the upfront purchase price.
Right. The economics are really driving adoption there. But the absolute center of gravity for manufacturing and domestic consumption is still China.
Oh, without a doubt.
In 2025 alone, China saw 13 million EVs sold.
13 million out of the 20 million globally.
Yep. That represents a 55% market share in the country. More than half of all cars sold in China last year didn't even have a gas tank.
That is insane. But, that explosion wasn't entirely organic, right?
Right.
The Chinese government heavily stimulated that growth with this massive trade-in scheme.
Oh, yeah, the trade-in program.
They were offering 20,000 Chinese yuan, which is works out to about $2,750 to anyone trading in an older combustion vehicle for a new EV.
Which, it created this severe and totally unexpected market distortion.
Right, because people found a loophole.
Exactly. The government actually had to hit the brakes and temporarily halt the entire subsidy program in July of 2025.
Just pause the whole thing.
Yeah, they were running out of funding way faster than projected because of this sudden rise of what they called zero-mileage cars.
Okay, I was reading about this in the sources, and the mechanics of it are wild.
It's basically a massive arbitrage scheme.
Right. Like, dealership networks and individual speculators were buying brand new EVs on paper just to capture that $2,750 government check.
They had absolutely zero intention of driving them.
None. Once the subsidy cleared, they took these pristine, zero-mileage cars, legally reclassified them as used, and then just dumped them onto the domestic and global export markets at a steep discount.
Yeah, they basically turned a well-intentioned environmental policy into a financial printing press.
It's kind of brilliant in a very devious way.
It really is. But it flooded the secondary market with these heavily discounted new cars, which aggressively undercut legitimate used car sales. By the time the government finally paused the scheme, these zero-mileage flips accounted for a staggering 4% of all electric car sales in the country.
4% is huge when you're talking about millions of cars. It really paints a picture of a market moving almost too fast for its own regulations.
Definitely.
If we map out global EV adoption based on these sources, it feels like this massive train, right? But the cars aren't all sharing the same engine.
I like that analogy.
Yeah, like China is this high-speed maglev just pulling itself forward with brute force government subsidies and sheer manufacturing scale.
Right.
Europe is comfortably coasting in the passenger cars on the momentum of strict emissions regulations. And the U.S. is currently jogging alongside on the platform, just trying to grab a handle before the train leaves the station.
That is a perfect way to visualize the sales data. But, even with 20 million new EVs leaving dealerships globally, the industry is still slamming into this incredibly stubborn psychological barrier.
The charging time.
Exactly, the wait to charge. Because if the ultimate goal is near total adoption, you just cannot ask the average driver to completely redesign their schedule around a 30 to 45-minute pit stop at a highway charging plaza.
Nobody wants to sit at a rest stop for an hour.
Right. The technology has to match the speed of a traditional gas pump, or the adoption curve it'll eventually plateau.
Well, according to the technical specs released by BYD in March 2026, they might have actually shattered that plateau.
The megawatt flash charging 2.0.
Yes. And the raw engineering numbers here are just intense. They are delivering 1,500 kilowatts of power to a single vehicle.
Which is mind-blowing.
For context, Tesla's V3 and V4 superchargers, which are already fast, they max out between 250 and 500 kilowatts. BYD is engineering a system that pushes up to 6 times more power than what we previously considered ultra-fast.
Yeah, pushing that kind of volume requires a completely unified hardware ecosystem.
What do you mean by unified?
Well, BYD engineered a system-wide 1,000-volt high-voltage architecture, and when they pair that with their new Blade Battery 2.0, they can push a charging current of 1,000 amps.
Wow.
Yeah, in battery engineering terms, they achieved a sustained 10C charging rate.
Okay, so let's translate that for the listener. What does this all mean when you are actually standing there with the cable in your hand?
It means speed, incredible speed.
Right. It means you add 400 kilometers, so it's about 250 miles of range in exactly 5 minutes.
5 minutes? That's a gas station stop.
Exactly. You take your battery from a 10% charge up to 70% in the exact amount of time it used to take to pump a full tank of gas.
And the winter performance is what really got me.
Oh, yes. Because usually a freezing battery just chemically refuses to accept a fast charge, right?
Yeah, the lithium ions just won't move fast enough in the cold.
But BYD integrated this low-temperature preheating module. The specs show that even at minus 30 degrees Celsius, which is minus 22 Fahrenheit for our U.S. listeners, the system heats the battery core and pushes it to a 97% charge in just 12 minutes.
The battery chemistry breakthrough there is phenomenal. But, the physical delivery mechanism is equally challenging.
Oh, absolutely.
Because pushing 1,500 kilowatts of electricity generates an immense amount of thermal energy.
Right, I was thinking about this. The thermal physics alone should make this completely impossible for a consumer product.
You would think so.
Pushing that much current through a standard copper cable would generate so much heat that the cable would literally melt in your hands. Unless, I don't know, you made it as thick as a tree trunk.
Right, like a python.
Yeah. How is an average driver supposed to wrestle a 50-pound boiling hot cable into the side of their car?
Well, they don't. BYD knew the physical cable was the bottleneck, so they completely redesigned the charging station architecture. They came up with what they call a zero-gravity system.
Zero gravity.
Yeah. Instead of dragging this heavy, liquid-filled hose across the concrete, the station is billed as a cyan and dark gray T-shaped overhead canopy.
Okay, so the cable hangs from the roof rather than sitting on a big box on the floor.
Precisely. It hangs from a sliding pulley system mounted directly on the canopy, so you are never fighting the weight of the copper or the internal coolant lines.
Oh, that makes so much sense.
Yeah, and the cable itself utilizes this advanced all-liquid cooling loop to manage the extreme heat of that 1,500 kilowatt transfer. Because it's suspended and counterweighted, the actual portion of the cable that you, the user, interact with weighs only 2 kilograms.
That's just about 4.4 pounds.
Exactly. Very easy to handle.
And since it's on a slider, it doesn't even matter if your charge port is on the front left fender or like the rear right bumper.
Yeah.
You just pull the cable right over to it.
No more awkwardly inching forward and backward.
Right. And the sources also mentioned this allows for true pull-through parking. You don't have to awkwardly back a trailer into a charging stall anymore. You just drive straight under the canopy.
The physical ergonomics are totally solved. But honestly, the electrical hurdle is actually much more dangerous.
How so?
Think about it. If 4 vehicles pull into that canopy and demand 1,500 kilowatts simultaneously, that station is suddenly pulling a 6-megawatt spike from the local grid.
Oh, wow. Yeah, 6 megawatts hitting a local neighborhood grid all at once would cause massive voltage drop.
It would be chaos.
You'd be blowing transformers and causing rolling blackouts just because 4 people wanted a quick charge on their way to work.
Exactly. So to prevent that, BYD is leveraging their core business.
Yeah.
They are fundamentally a battery manufacturer.
Right.
So they are not pulling that 6-megawatt spike directly from the public utility. For their planned rollout of 20,000 Chinese stations, every single site is paired with an on-site energy storage buffer.
Like a massive battery pack just sitting there.
Exactly. A stationary battery installed right next to the chargers.
So the station is acting like a giant reservoir. It just sips power slowly and continuously from the public grid 24 hours a day.
Yep, storing it up safely.
Right, without stressing the neighborhood transformers. Then, when a car plugs in, the station doesn't ask the grid for the power. It rapidly dumps its own stored reservoir directly into the vehicle.
It creates this perfect protective firewall between ultra-fast charging and aging grid infrastructure.
That is so smart.
And it also means they can deploy these megawatt stations in rural or grid-constrained areas without waiting years for multi-million-dollar utility upgrades. Plus, BYD is opening these stations to the public, meaning any brand of EV can plug in.
Though, if you pull up in a brand new non-BYD car, say, a top-of-the-line Tesla, you aren't going to get that 5-minute, 400-kilometer charge.
Right, you're hardware limited.
Exactly. The charging station might be capable of pushing 1,500 kilowatts, but your car's internal hardware will physically throttle it. A Tesla will still only pull its maximum of 250 kilowatts.
Yeah, it's a bottleneck.
It's like having a gigabit fiber optic internet connection piped into your house, but you're still using an old Wi-Fi router from 10 years ago.
Yeah.
You're completely capped by your own hardware.
That's a great comparison. And, the Chinese market is currently prioritizing that raw speed and hardware innovation. But the U.S. market, on the other hand, is heavily focused on unification and reliable access right now.
Right. Less about pushing the speed limit and more about making sure everyone can just plug in somewhere.
Exactly. And the major news for late 2025 on that front is Volkswagen officially joining the NACS, that's the North American Charging Standard, as of November 18th.
Which is huge. This finally gives VW owners native access to the Tesla supercharger network, which has really been the gold standard for reliability in North America.
For sure. But the transition is still a bit clunky.
Yeah, it's not seamless yet.
No. VW is selling a CCS to NACS adapter to their current drivers for $200, though they are offering a $100 rebate if you happen to be the original owner of a 2025 ID.4 or ID Buzz.
Right, which helps. But Volkswagen had initially promised that their new fleet would feature the NACS port natively built into the hardware by 2025.
Yeah, that didn't happen.
No, the supply chain and engineering timelines clearly slipped. The upcoming Porsche Cayenne EV will actually be the first VW Group vehicle to roll off the assembly line with the port integrated right from the factory.
Which is a step in the right direction, finally.
Definitely. Which actually brings us to the most profound shift in all these sources today.
The grid stuff.
Yes. We just talked about BYD locking massive stationary batteries next to their chargers to protect the grid, right?
Right.
But wait, the station is already surrounded by massive batteries. They're sitting right inside the cars parked out front.
Exactly.
If a car sits parked and idle for 95% of its life, why aren't we just using the cars to protect the grid?
What's fascinating here is that the industry is finally doing exactly that. We're talking about vehicle-to-grid or V2G technology.
Now, if you follow the EV space, you've probably already messed around with V2L, that's vehicle-to-load, where you use your car to power a camping fridge or charge a laptop out in the woods.
A super handy feature.
Or maybe you've looked into V2H, vehicle-to-home, where your car acts as a backup generator to keep your house running during a blackout.
Right, keeping the lights on.
But the sources point out that V2G, where your car actively pushes electricity back into the public utility grid to balance neighborhood demand, is finally hitting commercial reality.
And the bottleneck for V2G was never really the physical batteries, it was the software communication
They
standards.
just couldn't talk to each other properly.
Exactly. But the new ISO 1451-1820 standard finally enables two-way energy transfer and secure communication on the dominant CCS2 charging connector, which is what's used all across Europe.
Oh, nice.
Yeah, before this, bidirectional charging was highly fragmented. It was mostly limited to the older CHAdeMO plugs.
Right, the CHAdeMO plugs. But now that the standard is unified, major automakers are moving really quickly. The Renault 5 E-Tech, the Mercedes GLC, and the BMW iX3 are all actively participating in V2G networks today.
And the economics of this are what truly changed the ownership model.
This is the part that blew my mind.
It's wild. In Germany, EON and BMW have partnered to actually compensate drivers. They pay 0.24 euros per hour just to leave the car connected to the bidirectional charger.
Wait, just for plugging it in?
Yep. You can earn up to 720 euros a year just for being plugged in and available to the grid. And on top of that, they pay you 40 cents per kilowatt hour for the actual electricity the grid temporarily borrows from your battery.
That is amazing. But transforming a car from, a depreciating asset into a revenue-generating node on the energy grid that required changing national laws, right?
Oh, big time.
Up until November 2025, if you participated in V2G in Germany, you were hit with these double grid fees.
Yeah, the bureaucracy was killing it.
The utility charged you a toll to pull the power into your battery, and then they charged you another toll when you pushed it back to the grid. It completely wiped out any profit margin for the driver.
It makes zero financial sense.
Right. But Germany finally amended the Energy Industry Act to classify EVs participating in V2G as stationary battery storage, legally ending that double dipping.
Which opened the floodgates.
Okay, but here is the inevitable pushback from literally anyone who just bought an EV.
I know exactly what you're going to say.
The battery pack is by far the most expensive component of the vehicle, right? If I let the local power company remotely cycle my battery, draining it during the afternoon peak and filling it back up at night, that constant chemical wear and tear is going to degrade my battery and ruin the resale value of my car.
Yep, that's the fear.
Why would I sacrifice a $15,000 battery to make a few hundred euros a year?
It is the most common concern among EV owners by far. But the chemical reality tells a very different story.
Okay, lay it on me.
A comprehensive study published in the journal Applied Energy tracked and modeled V2G usage over a full 10-year lifespan, and they found that actively participating in V2G networks adds only 9% to 14% extra battery degradation over that entire decade.
Wait, 9 to 14% over 10 years?
That's it.
That equates to roughly 0.3% of extra degradation per year. That is practically a rounding error.
Exactly.
How is the wear and tear so incredibly low if the battery is constantly moving power back and forth?
Well, if we connect this to the bigger picture of battery chemistry, between 85% and 90% of a lithium-ion battery's degradation is purely calendar aging.
Calendar aging, like just getting older.
Literally just getting older. The internal parasitic reactions in lithium plating, they happen simply because the battery exists and is exposed to the passage of time and, ambient temperature fluctuations just sitting in a driveway.
So it's going to degrade whether I use V2G or not.
Precisely. The careful, software-managed charging and discharging required for V2G adds almost no mechanical stress to the cells. As long as the system prevents extreme deep discharges, which the software does, the financial compensation significantly outpaces the fractional wear on the battery life.
Wow. That completely flips the script on what car ownership actually looks like. Your vehicle is literally earning its keep while you sleep.
It's working a night shift for you.
It really is. So let's look at the totality of what we've covered today. We started this deep dive exploring a global market where 1 in 4 new cars rolling off the lot is fully electric.
A massive milestone.
We saw how BYD's new architecture allows you to add 400 kilometers of range in 5 minutes, utilizing these suspended liquid-cooled cables to manage megawatt power safely.
Erasing that charging wait time.
Right. And we unpacked the commercial arrival of V2G, where your parked car actively stabilizes the neighborhood grid while generating passive income for you.
The underlying theme of all these sources today is a fundamental shift, from vehicles that just consume energy to a deeply interconnected network of vehicles that intelligently manage, store, and distribute energy.
Absolutely. And I want to leave you with one final kind of mind-expanding idea that was buried deep in the margins of that IEA report.
Oh, this part is fascinating.
The report casually notes that fully electric, autonomous driverless taxis are already operating commercially in 20 cities around the world right now.
20 cities already.
Yeah. So I want you to ponder the synthesis of those technologies.
Oh.
What happens when you combine commercial vehicle-to-grid energy trading with autonomous driving?
The possibilities are endless.
Are we looking at a near future where your car drops you off at work, and instead of paying for a downtown parking spot, it drives itself to a suburban charging station to buy dirt-cheap solar power at noon?
And then holds on to it.
Right. Then it drives itself across town to plug in and sell that stored power back to the grid at a premium during the 4 p.m. demand spike.
Just playing the energy market.
By the time it picks you up at 5 p.m., your car hasn't just provided transportation. It has actively traded energy markets to make a profit for you that day. Is the 100-year era of the car functioning purely as an expense finally coming to an end?
It's wild to think about, and this raises a really important question for regulators and automakers alike. Because if the trajectory of 2025 and 2026 holds, that highly automated, profitable future is arriving much faster than our current infrastructure is prepared for.
It really is. It's enough to make you look completely differently at the gas station on the corner.
Yeah.
That century-old ritual is officially running on fumes. Thank you so much for joining us on this deep dive. Keep questioning, keep learning, and we will catch you next time.